Question 4, we've got an equation, fx, and here is the differential involving cos x. And we're told that the curve is a stationary point where x is equal to alpha. Alpha is small, and we've got to use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. Okay, let's first of all write down the small angle approximation for cos x. Now, this small value of x, which is alpha, has a stationary point, and this is the gradient function, so the gradient at that point will be 0. So the equation I can set up is that 0 is equal to 2 alpha plus a half, all this lot, 1 minus alpha squared over 2. And if we split that bracket apart, we get 2 alpha plus a half minus alpha squared over 4. To get rid of these denominators, multiply everything by 4. So therefore I can say that 0 is equal to 8 alpha plus 2 minus alpha squared. A quadratic in alpha, put that into a calculator, and we get that alpha is equal to 4 plus or minus 3 root 2. So this offers 2 solutions. 4 plus the 3 root 2 and 4 minus the 3 root 2. 4 plus the 3 root 2 is not small. So 4 minus 3 root 2, it can be the only solution we're looking for. And if you put that into a calculator, you get the answer that alpha is equal to negative 0.243. And that's to 3dp. And that's your answer. So part B, by the way, this diagram is not supposed to be anywhere representative of the curve, but it's just illustrative of what we've got to solve. We've got a point P lying on the yellow curve, and we have to find the equation of the tangent at that point. So we know the gradient function, so this is the value of the gradient at every point along the curve. We need the gradient at the point where x is equal to 0. So if I substitute x is equal to 0 into this, I will find the gradient of our blue line. And because we know a point on that, we can find the complete equation of that blue line. So let's have a go. And if we do that, this term will disappear, and this will just be a half cos of 0. And the cos of 0 equals 1, so the gradient is equal to a half. So that's got the gradient of the line. We know a point on that line, which is 0, 3, so we just set up the usual gradient equation that we need. Y minus y1 divided by x minus x1 is equal to the gradient. So I get a half, putting our values in, I get a half is equal to y minus the y coordinate, which is 3, divided by x minus 0. Shifting this all round, we get that y is equal to a half x plus 3. So the constants we need to find is that m is equal to a half and c is equal to 3. And that will gain you the 2 marks on offer.